Hello students, today we'll discuss real analysis Sem3. In this first topic is sequences. So sequence is nothing but a function from natural number to real numbers. So sometimes we are taking whole number, it is in some particular case of course, but generally it is a mapping or function from natural number to real numbers. In this it is generally denoted by Sn where the terms are writing as s1 s2 s3 like this. So this is in this s1 is called first term, then s2 is second term, like that we are taking. Now see one example. Take Sn. One sequence is given with n term. What is n term here? 1 by n square. So how to find the sequence elements means, what is the domain here? Natural number. So substitute n equal to 1 2 3 4 like that. Then when you are substituting in this, then what will get? 1 by 1 square, 1 by 2 square, like this will get. So these are the range elements. So when you are taking the in the function, this is natural number 1 2 3, always we are taking natural numbers, then you are getting different range elements, like here 1 1 by 4, 1 by 9, like this. So what we can see here, always the domain is natural number, so no need to write every time all natural numbers because it starts from 1 2 3 obviously. So only in the sequence we are taking the range elements. What are the range elements here? 1 1 by 4. So in the sequence, actually this is a function from one set to another set, but generally in the sequence we are taking the range elements like 1 1 by 4, 1 by 9, like that. Similarly, one another nth term is given in the sequence. To find the elements, what we have to do? Domain is natural number. So substitute n equal to 1, then we are getting minus 1, n equal to 2, 1, n equal to 3, minus 1, like this. So what are the sequence elements here? Here minus 1 1, minus 1 1, like this. Similarly, we can see another question. Sn is given. To find the sequence elements, simply substitute n equal to 1, n equal to 2, n equal to 3 in this. Then 1 plus 1 by 2 into 1 plus 3, that is 2 by 5. Like this, we are getting the sequence elements. So this is called first term, second term, third term, like this we can write. Now to find the sequence terms for the another problem. So to find the sequence terms for Sn equal to cos n pi by 3, substitute n equal to 1, then cos 1 pi by 3, that is 60 degrees. So obviously we know that cos 60 is 1 by 2. So when finding the second term, 2 pi by 3. So how to find cos 120 degrees? So we have some rules. Let us see that. First of all, we need to learn this table, sin 0, sin 30 up to sin 90, like this. All the values you should remember. So here we have another basic condition. We are taking this total into 4 parts. First quadrant, second quadrant, third quadrant and fourth quadrant. Here this is 90 degrees. So all the below of this part will be 90 minus theta, like 30 degrees, 40 degrees, 50 degrees. So 90 minus theta. Here 90 plus some angle is there. So 90 plus theta, 180 minus theta, up to here 180. Again 180 plus theta, 270 minus theta. Again here 90 90 90, 270 plus theta, that is 270 plus theta, 360 minus theta. After one total circle, again we should take it as 360 plus theta. Then for 90 degrees and 270 degrees, sine changes to cos, cos changes to sine, tan to cot, cot to tan, cosec to sec, sec to cosec. 180 to 180 degrees and 360 degrees, there is no change. So sine means sine, cos means cos, like this. So how to remember all those things means, you should learn this table and these conditions. And also sin n pi is always 0 for all n. That means sin 2 pi, sin 3 pi, sin 100 pi, whatever you are taking, the value will be 0. And sin n pi, where n is even number, then we can write the answer as 1, like 2 pi, 4 pi, 6 pi, answer is 1. And for odd number like 3 pi, 5 pi, 7 pi, the answer will be minus 1. So to solve this problem, you should remember all these conditions, right? Now let us see. To find the second term, 2 pi by 3 means 260 is how much? 120 degrees. So 120 degrees we can converting into either 90 or 180 or 270. Which one is near? We have to converting into that one. So we can write as 90 plus 30, or else you can write as 180 minus 60. Anything is fine. Now what we should do is, first of all, we should take 90 plus theta. Cos 90 plus theta means 90 plus theta means it is in second quadrant. So here only sine and cosec is positive, are positive, remaining all are negative. Here always we remember one more thing: all silver tea cups. All silver tea cups means in the first quadrant all are positive, in the second quadrant only sine and cosec are positive, remaining are negative. Here tan and reciprocal cot are positive, here cos and sec are positive. So here cos 90 means in this 90 plus theta cos is negative, only sine and cosec are positive. So for cos we have to take negative. And also 90 plus means for 90 and 270 what will happen? Cos change it to sine, that's why we are taking here sine, and 30 degrees as it is. So sine 30 according to the table we can write as minus 1 by 2. Similarly, for 3 pi by 3 means 3 into 60, that is 180 degrees. 180 we can write it as what? 90 plus 90. Again sin cos 90 means here minus, so minus 90 means cos changes to sine 90. Sine 90 is minus 1. Like that, here fourth term is 240 degrees means we can write 180 plus 60 or 270 minus 30. Anything is fine, we can get the same answer. So cos 270 minus means it is in the third quadrant. In third quadrant also cos is negative, that's why negative. And 270 means cos changes to sine, that's why here sine 30 degrees. So it is minus 1 by 2. So like this we can find all the terms for this cos n pi by 3. Now students, series. Next topic is series. Series is also similar to sequence, but series is nothing but infinite sequence of real numbers. Then their sum s1 plus s2 plus s3 is the infinite series of real numbers. So when you are taking sequence as what? S1 comma s2 comma s3. When you are adding, when you are taking the sum of all the sequence elements, how many elements in a sequence? We can't say, because when you are substituting the domain set as natural numbers, so we are substituting 1 2 3 4 and so on, we are getting different numbers. So it is not finite, right? It is infinite. When you are taking the sum of all that infinite numbers, then it will become a series. So sequence is nothing but what? Arrangements of numbers in a particular order, whereas series is nothing but the sum of elements of the sequence. Now range. What is the range? The set of all distinct terms of the sequence. Already we discussed sequence is nothing but is mapping from natural number to real numbers. What we are taking in the sequence, we are not taking like here we are not taking for one the value is 2, not like this we are taking, right? So only obviously every time we are substituting 1 2 3 4 and so on, that's why we are not writing domain every time. Only we are writing what? Second terms, range terms we are writing here, right? Range is nothing but the what? Second set in the function. So to find the set of all terms of the sequence is called the range. So to find the range of a sequence, what we need to do? Just substitute 1 2 3 4, then you are getting what? Range elements. So see here, when you are substituting 1, what will happen? Minus 1 will come. 2 means 1, 3 means minus 1, like this. When you are taking the sequence element, what will come? Minus 1, 1, minus 1, 1. So all the distinct terms, range is nothing but what? All distinct terms of the sequence, only distinct terms. So it should not be repeated. So only distinct terms are what? Minus 1 and 1. That's why the range is minus 1 and 1. Understood? So see here, here also range of the sequence means when you are substituting 1, 2 into 1 means 1 by 2. Here 2 2s are 4, 1 by 4. See here, 3 means 1 by 6. So what is the sequence here? 1 by 2, 1 by 4, 1 by 6, and no one is repeated, right? So all are distinct elements. So the range is nothing but distinct terms in the sequence. So you should write all the terms in the sequence. That is, range is nothing but this one. So what is the difference between range and sequence in the sense? Sequence means you should take first term, second term, third term, like this. And range in the sense we are taking as a set which is having the distinct elements. That is the difference between range and sequence, right? Now see the next one. Find the range of the sequence. Obviously substituting a 1 2 3 4 in this, then you are getting the values. This is nothing but the sequence and all are obviously distinct. So we are writing everyone in the range, take as a set. Now constant sequence. Constant sequence means range is always same. That means when you are taking 1, the answer is 2. When you are taking 1, 2, 3 in the domain set, right? And what is the range? Answer is always, suppose some constant C. It is related to only one element constant, then we can say it is a constant sequence. See here, for example, 2 is given. So range is what? 2. Means first element, second element, third element, all elements are 2 here. That's why this is said to be a constant sequence. Okay, in the next video, we'll discuss limit of a sequence, convergent and divergent of a sequence with examples and problems. So thanks for watching.